If you are here to learn about modern SQL Server features that make life better, you're in the right spot. I really appreciate the GroupBy conference people voting me in, and appreciate the sponsorship from Fortified. And it's great to see this particular conference back online. So a little bit about me. I accidentally fell into IT back in 2008. I took a job where I thought I was just going to be doing some app support for the company I was working for at the time. And we've all heard the saying that curiosity killed the cat. In this case, my curiosity lunged me forward into a career into IT before I really realized that that was even really happening. Did the work of a database administrator for a few years, and then was finally granted the official title after doing that work. I blog at leemarkum.com. So if you like what you hear today, go check out that website and to look at the blog post there. I've done a fair amount of speaking, but still relatively new as well. So spoken at meetups. I was at New Stars of Data back in 2021. I had the great pleasure of doing an online session for PASS a couple of years ago. And most recently, I spoke at St. Louis DevUp. I'm in St. Louis, Missouri, kind of central part of the United States. And that was a fun conference to be at. Currently, I am a senior database administrator at Rocket Companies, which is, you'll all recognize that more as Rocket Mortgage. It's more than just Rocket Mortgage, but people know that name. Of course, views here are my own. What I'm saying today has nothing to do with my current employer. There's some contact information on the screen, and feel free to use that afterward to talk with me about anything really. So I want to set some expectations. The goal here is to introduce the useful modern features. I can't provide in-depth coverage in an hour. Each one of the sections that I'm going to talk about could be whole presentations in and of themselves. So I say that to help you realize that you're getting an introduction. You're not getting in-depth information today. And that if you had a feature that you hoped I had talked about or was going to talk about and didn't make it into the list, again, my apologies, but I have to make some choices. I am sticking to just things in the database engine because that's what I know. So there's no information about changes in, integration services, reporting services, other components, that sort of thing. Beyond what I just told you, how else did I make a decision about what I was going to talk about today? So I'm sticking with features that were started in supported versions of SQL Server. To me, that's what modern means. It means it's supported. It's current enough that Microsoft's going to keep working on it. So that means, for the most part, I am not going to talk about things that came into the product in SQL Server 2012 or even 2014, because that's now past end of life as well. There are a few exceptions, and that's because those features are still being worked on and developed. So for the agenda today, we're going to talk about these 4 categories of things. We're going to be looking at performance. There are some very interesting and great things performance-wise that are new in modern SQL Server. There are some troubleshooting things that I really like. We're going to take a look at some T-SQL enhancements and then talk about high availability and disaster recovery enhancements as well. So performance features. One of the first performance feature I want to talk about is lightweight query profiling. There is a previous version of this called standard profiling. It was a little more intensive, gathered more metrics. But what's different about this is that lightweight query profiling is really on by default. In the standard profiling feature, you had to collect the SQL Server statements or T-SQL statements that you wanted to get the performance metrics for, and then turn some settings on, rerun it in order to get the performance metrics that it would offer. Lightweight query profiling will do it live. So with this enabled with trace flag 7412 in 2016 and 17, you can even see live query performance back in those earlier versions of SQL Server as well. And you can use sys.dm exec query profiles to do something that really you couldn't do before, as far as I know, because I've looked to see what are the answers to this, which is, how do I find out how long it's going to take for this index to make? Or how can I estimate how long it's going to take? With lightweight query profiling, you can actually do that. And so that's a very nice application of this particular feature that I have used quite frequently. Here's a big diagram from Microsoft Learn that talks about their intelligent query processing. It is a family of features. This by itself could be several days worth of material. So obviously we can't talk about all of these things. I'm going to look at a few specific features. And you can see it spans several different versions. We had 17, 19, and 22 up there as well. So the first thing we're going to talk about in terms of intelligent query processing features is memory grant feedback. Now, we got that in SQL Server 2017. This doesn't require the query store, as it does affect the plans that are cached. We can use this to reduce spills to disks by increasing memory grants. So what this does is it will it sees a query that's incoming. It notes the memory that's been granted to that query. When it sees that query again, if there was a spill to disk, then what it will do is it will increase the memory for that particular query. And then as it continues to see this same query, it may adjust up or down depending on the memory that's been granted each time. Now that can unfortunately result in this kind of zigzag up and down effect, where it grants a lot of memory, it doesn't spill to disk, but then it also doesn't use most of that memory. So then it grants less, then it spills to disks, so it grants more. It's a mechanism that's meant to help you kind of manage and better utilize memory. This information is lost when the SQL Server is restarted, or if your query is using recompile, then that memory grant feedback information doesn't carry through to the execution, so it can't really analyze what's happening with a particular query. Databases do need to be on compat level 140 for the batch mode version of this, and then 150 for row mode. There is a way to track the memory grant feedback with an extended event there that you see on the screen called memory grant updated by feedback. So you can track this particular feature and what kind of effect it's having on your workload using extended events. And that's a very nice feature to kind of be able to see what's happening with the SQL Server and the queries that this feature is affecting. In SQL Server 2022, you get persisted and percentile memory grant feedback. You do have to have the query store turned on, and it has to be in the read-write mode. So what this particular feature does is it smooths out that zigzag effect that I talked about before, so that you get a more even allocation of memory to the queries that this particular feature is having an effect on. And I really like the progression of this feature, and I really see that it does have benefits in terms of being able to manage memory better. You're not wasting memory, you're not underutilizing it. You get a better curve of the memory that's being granted to your queries. And particularly if you're in the cloud, if you can use this kind of feature and others that I will talk about to better manage your resources, you can actually lower your costs in a number of ways. So if you're on AWS infrastructure as a service using EC2, for example, VMs, or even Azure VMs, and you're using some of these features I'm going to talk about that can actually, bring down the resource usage of your system, then you could actually lower the size of your EC2 instance. Any questions so far, Tab?
No questions so far.
Okay.
So please go ahead. Yeah. Yeah. No, there's some side chat going on about the video editing. Sorry, go ahead.
Okay. The next performance feature that I want to talk about is DOP feedback, or degree of parallelism feedback. This is a SQL Server 2022 feature. Databases do have to be in compat level 160, which is SQL Server 2022. You have to have query store enabled and in the read-write mode. And what this feature does is, much like memory grant feedback, it will analyze incoming queries that are stored in the query store. And let's say that you have max stop is set to 8. So when a query goes parallel, it uses 8 cores on that particular query. This feature will then say, when it sees that same query structure again, what if we tried 4 CPU and it runs it with less CPU when it goes parallel? And then it does some heuristics, some metrics, and to determine, when I used only 4 CPU, did the query finish with roughly the same performance? If yes, then it will keep going down the DOP feedback chain until it reaches a regression. So let's say we get down to, it goes down to 2 for that same query it sees later, and the performance just isn't as good. The duration is longer, and the system will see that and says, okay, got it. I can't go down to 2. I'm going to use 4 as the degree of parallelism for this query structure every time I see it going forward. And it persists that information in the query store. And so that's why the query store has to be turned on. It has to be in read-write mode. You can see the feedback information in a DMV there, sys.queryStorePlan feedback, and it will show you the different steps and processes it goes through, including the stable or persisted or verified feedback. I think it's called as verified feedback. So we talked a little bit about Query Store already and how it feeds into memory grant feedback in later versions, where it stores that information and then uses that in a persisted way and in DOP feedback. And I recognize that maybe this particular audience is familiar with Query Store, but this is in here because at every place I've been and people I talk to, there's still a lot of people who don't even know what Query Store is. So I feel like it's a wonderful feature that is going to give us a lot of query runtime performance metrics from the perspective of CPU, duration, logical reads, and a lot of other ways to slice and dice how your queries are performing. And I use this almost every day to analyze queries, troubleshoot performance, and address those very common scenarios where the app team calls up in some fashion and says, yeah, it's slow. And that's the only information you get. Well, Query Store can help pretty quickly determine, where things have been slow recently, or when things were slow last week, and you get that question. Query Store helps you with that. There was in 2017 the addition of wait stats information, so you can see things like page IO latch weights and CPU memory weights and parallelism type weights now in 2017 and above for the information that's in Query Store. When it did first roll out in 16, there were some edge case scenarios where there were some performance issues that it created, but as the product has become more mature, they continue to address that. And one of the things that they did in 2019 was create this custom capture policies where you can actually say that queries have to use a certain amount of CPU in order for them to be captured, or they have to run for a certain duration, and that helps filter down the data that's being collected by Query Store. It is a database level setting. Again, it stores not only the performance metrics I talked about before, but it stores query plans, and you can use that to detect regression. There are a number of built-in graphical reports that will give you quite a bit of information, and one of them is a regression report. You can also use Query Store to force, good query plans that are resulting for your workload in having a better overall performance. Now, forcing a good query plan isn't really meant to be some sort of permanent solution. It's meant to fix the problem that you're having right now. And then ideally, you go back and look at all the plans that you're forcing. You work with your app team and say, is there a way to rewrite or to do something else to like stabilize the performance? And also, I just wanted to say that there are certain circumstances in which forcing a good query plan doesn't actually do anything, because the next time that query runs, it might not meet all of the parameters that are necessary in order for Query Store to actually force the plan that you selected. So it's not a 100% foolproof go faster button. I don't really think that's ever going to exist, regardless of how badly we all probably want it. There are a couple of important trace flags when you're going to use Query Store, and one of those is 7745. And what this does is Query Store has a lot of its information stored in memory, and every usually 15 minutes it flushes that information down to disk. This is a performance enhancement because you don't want it constantly writing the information to disk. That would definitely be a performance issue. But what they found was that when you go to restart your SQL Server or you have patching and the system reboots, that Query Store was trying to write that data to disk, and it was stopping the server from stopping and shutting down and restarting. And so 7745 will actually eliminate that problem. Now, you do lose the 15 minutes of data, but if you're rebooting your system, you probably have a good reason to do that, and you don't want to delay that reboot over 15 minutes of performance data. Interestingly enough, I learned recently that this trace flag is not available in AWS Relational Database Service. So if your company is using AWS RDS, just be aware that this trace flag isn't available for you to use. Yeah, we'll stay at that. Trace flag 7752. So this is kind of the opposite of the other one. This will let Query Store load its data into memory upon startup and still let queries run. So what was happening before was Query Store would try to load up memory or data into memory, and it was preventing queries from executing because it needed to load this data into memory in order to capture queries. And so 7752 lets Query Store load that data into memory while still letting executions of queries happen. Now, again, it does mean that you're going to miss a few query executions, but I'd rather have my system running and miss a few things here and there. Again, obviously, you want your system to come up as quickly as it can to service your workload. Query Store is a fantastic tool for a before-after picture for migrations. And so what I've done in the past is Query Store will, by default, I think it holds 30 days of data. You can obviously hold more, but if I'm going to do an upgrade on November 1st, then what I can do is make use of the information 2 weeks before November 1st and 2 weeks after and do a comparison. So you can get your topmost CPU performing. You can get the queries that use the most CPU in the 2 weeks prior, and then you take those query IDs and you compare those same query IDs in the 2 weeks after, and you can see which queries performed better, which queries performed worse. You can do that with a number of different metrics. So Query Store is a great before and after kind of feature that lets you see not only just regression, but like I mentioned, positive impacts of performance or that a particular upgrade has had for you. And I always like to be able to show people that all the work of an upgrade has been worthwhile. So I really like that part of it. I did mention that Query Store is essential to a couple of the different features in SQL Server 2022, the memory grant feedback, DOP feedback. There's also another one called cardinality estimation feedback. You have to have Query Store enabled and turned on in order to get those features in SQL Server 2022. So troubleshooting features. What's new? What's helpful that makes our life better and easier in terms of troubleshooting?
Lee, do you mind answer a few questions before you
Sure.
get there?
Yes.
Because okay, so the first one is from Srinivas. Memory grant shows only when sort or hash operator in execution plan. Queries without these operators, how do we know how much memory consumed by the query?
Okay. um, that is an excellent question, and I don't know if I know the answer off the top of my head. There is what I would do to answer that question is look at the wait stats information that's in the Query Store reports and see which queries are experiencing weights related to memory, and there is information in there about how much memory is granted. Beyond that, if I'd have to look it up and get back to you.
So I can chime in a little bit. Even if you don't have a sort or a hash operator, you can still go, if you have your execution plan, you can still go to the XML, or in SSMS, there is a new thing called memory grant info. If you go to your node number 0 and look at properties and you expand it, you'll see it.
Okay.
Yeah. And the next question is from Arthur. Regarding DOP feedback, does it consider actual instance-wide condition like other workload that can affect the performance of an examined query at a specific DOP level?
I'm sorry.
I'll
Can you?
repeat it. Sorry.
Yeah.
Regarding DOP feedback, does it consider actual instance-wide conditions, question mark, like other workload that can affect the performance of an examined query at a specific DOP level?
So I think what you're asking is if so let me answer it this way. If you have something in your query that's setting the DOP level within, you have a hint in that query, then the query hint will take effect versus the DOP feedback. If you have something at the database level, then I am not sure if that database level DOP feedback value would or max top setting would take precedence over the DOP feedback or not. Assuming that your database max top setting is the same as the server, then DOP feedback has free reign at that point to make changes to the max top for a query. Hopefully that answers your question. If not, I guess you can try asking it a different way or reach out to me and I'll try to get an answer on that.
And last question from Srinivas again. Query store does not have filter predicate like for a particular session. Store procedure or duration more than 300 millisecond or CPU over 1000 millisecond, etc. Is there an option internally introduce filter conditions?
Not out that I know of, not outside of doing something with extended events. That would be the only way I would know at the session level. If you want to know a particular session or login level information, That would be the only way I would know to do that, because you're right. A query store doesn't tell you what session ran it, or what login was involved. It captures the query information only in the query performance metrics.
I think in newer version you can set filter what to collect in query store. So you can set some parameters. So if you do not want the low hanging fruit, you can exclude those from for getting logged into the query store. I'm not sure if the question is, if my comment is relevant or no, but I know on the newer versions, I don't know from which one, you can set up something like that.
Yeah, so if if you don't care about what session or login it came from, then yeah, you're right. You can use the custom capture policies that came into the product in 2019 to say, the CPU has to be, so
Right.
much, or the duration has to be so long in order for it to actually capture a query.
Okay,
Uh,
that's it for now. So go ahead, and if there's more, I'll pass it to you later on.
okay, great.
Thanks.
So for a long time, I know that this was been a connect item. It's been in the vast array of feedback mechanisms that Microsoft has had. There have been various feedback items saying we'd like more information about this error that we see on the screen. String or binary data would be truncated. The statement has been terminated. Everybody in the world knows that if it knows that, it knows what happened to the data, what string was going to be truncated, and we were begging for Microsoft to give us a little bit more. Well, you're in luck because in 2019, you actually get that information. So when you have a SQL Server agent job that maybe you've never seen before, but it fails, and you get this string or binary data would be truncated message, you get a lot more information down to the column name and the value that was going to be truncated. No more spelunking through tables and stored procedures to just to pinpoint the issue. So this is a great benefit to people who have to troubleshoot these kinds of problems that happen with your data. This was backported into 2017. So if you use tracelag 460, you can get this verbose warning in SQL Server 2017 as well. And it's just on by default in SQL Server 2019. Temporary tables / system version tables. I have this in troubleshooting features because this is really a feature I like to help with auditing, and we'll see why in a few minutes. So what are these things? It's composed of your normal or system version table and a history table. Then you have a special start and end time columns that get added to your normal or system version table and your history table. Now you can hide these columns. So for everyone who just heard what I said and thought, great, we got to add columns, it's going to mess up all of our queries. You can hide those columns in your system version table, so that if you're doing a select star, for an example, for whatever reason, you don't get those columns back. The temporary table or temporal table must have a primary key. So those are just some basic things that have to be in place in order to use this particular feature. So this can be a replacement for triggers as a means of tracking changes to tables. So it doesn't give you, the one thing it's not going to give you is the who. It won't tell you who made a change to a set of data or a set of rows. But Aaron Bertrand, who's prolific at blogging and talking about all kinds of features, has a blog about it on MS SQL Tips at that bit.ly, where you can combine temporal tables and some other code to get the who. If you need to track the who as well as the what, but you don't want to use Aaron's method, there is a new feature in SQL Server 2022 called Ledger. I'm not going to be talking about that. I'm just pointing out that that Ledger feature will get you both of those things. So temporal tables can help you answer, what happened to the data and when did that particular change occur, which makes it really useful for auditing information. You can run queries to show trends over time. So let's say you have a sales table and you want to know what the sales information has been like over the last 6 months. Well, if you use temporal tables on the sales table and you're keeping that information for that long, which may sound scary, by the way, but logging information into the history table isn't going to double the size of your tables. The point is, you can run queries against the history table to see what sales were like for a particular product over time and trend that information. It's also, this feature is also really great for oops deletes and other changes that happen to the system. So if you have a developer who, we'll have an example in a minute, if you have a developer who, or even you're the DBA and you delete data you didn't expect to delete, or something goes wrong in production, if it's on a temporal table, those changes will get logged to the history table, and then you can actually use the history table to retrieve and fix the data. So let's say you have a multi-terabyte database, 2, 4, 6, 8 terabytes big, and someone comes to you and says, an hour ago, I realized that an hour ago when I made this change, it made changes that I didn't expect. We're going to need you to restore a database so we can fix it. Well, if you have a multi-terabyte database, let's say you're storing backups in Azure Blob or AWS S3, you have a 4 terabyte database, the backup is 2 terabytes. It's going to take a while for you to bring that database file down to a location where it can be restored. So after you spend all that time downloading the backup file, now you've got to restore it. So you've used 2, 4, 6 hours of time just to get to a place where you can even access the data. With temporal tables, you can start accessing the data immediately because it's in the history table. You would just use the start time and end time values for the rows that you need to find. So if you knew that the issue happened at 1 o'clock, then you can look in the history table for 1 o'clock and what did the rows look like at that moment. And you can use those rows in the history table, put those rows back, use them to update the rows in the temporal table. So let's kind of look at an example. Let's say that you need to increase, or you've been asked to increase the product price by 10%. And you, so what you're looking at here, those first set of rows where the price is $549.83, you have a system start and system end time. Those values represent, the sys start and sys end time represent when those rows were active or the valid rows in the original table. So when a 10% increase in the price occurred, it took the rows that were the original rows and put them into the history table, and now you have a new price in the source or temporal table. So let's say sometime later you're asked to do it again. We need to raise prices again. So then you have that second set of rows that you see where that price is $604 and some change. So now let's say a developer comes back to you and says, oh, that second 10% price increase, I didn't mean to do that. We weren't supposed to do that. Or whatever the reason is, that change wasn't supposed to happen. Well, again, if you have a huge database and you don't have this feature, now you're going through the painful process of restoring and doing side-by-side data comparisons and all of that. If you have temporal tables, though, set up, then what you can do is you can look at the system start and system end time, find what the valid rows were for that time duration, and then use those rows to do an update into your source or temporal table, and you're done. no waiting 2, 4, 6 hours just to get access to the data so you can start the comparison. You can start the comparison right away, which means customers aren't waiting on you to fix bad data. Internal folks aren't waiting on you for hours. So I really feel like this is a great tool, not only just to track and trend changes over time, but to help you fix data when there's some sort of an emergency.
So
Any
Lee,
questions?
yeah, Lee. So Samuel Jones asked, how much overhead is involving in turning temporal tables on and off? And then also Samuel made a comment. I'm speculating on maybe turning the feature on just before we do a deployment to production, for example.
Okay, sure. So I have not measured the overhead for this feature. So I used it a couple of jobs ago, and we didn't see any kind of problem or difficulty or performance hit that we were taking. I did get some questions recently about this when I was talking to an app team about this particular feature along the same lines. I didn't get a chance to actually capture metrics and talk to them about it. I can tell you it's not going to double the size of your database. A lot of people or of your table, a lot of people are concerned about how much history it keeps and what kind of bloat is going to happen to your table as a result of that. I've not seen any kind of major issue with table bloat as a result of this particular feature, and certainly it's not going to be any worse than if you were implementing a trigger system to do something similar. What was the second question, Tab?
No, I think that was not a question, probably a
Oh,
comment
comment.
Samuel made that I'm speculating on maybe turning the feature on just before we do a
Right.
deployment production, for example. So that was more of a comment about that, turning it on.
Yeah. And you could do that. Yes. My caveat or my concern about that is then you're not prepared for those oops delete scenarios, and you're going to wish that you had it when the random person comes to you and says, "Oh, I messed up the data." But certainly you can. It can be enabled and disabled for various at various times in order for you to do certain operations that are not allowed when temporal tables are turned on. So, okay, let's take a look quickly at T-SQL enhancement features. So one of the things I came across recently when I was revamping this particular section was file table. And I came across a post by Lewis Davidson about how he needed a solution for a scenario where he had a bunch of pictures that he was using to use as in his posting about Disney World and some other a couple of other applications that he had for this thing. And he talked about using the file table feature to hold these pictures, and would help him know what he had used, which pictures he had used, and when he'd used them and what they had been used for, so that he could see what pictures were still available for him to use. This could be interesting, like if you had an inventory database that people were accessing and you had pictures that you were showing your company's widget, whatever that widget is. Perhaps you could use a file table feature like this as well. Offset fetch has been around for a little bit, since SQL Server 2012. It's good for or user relationship to pagination. There's a bit.ly link there where Aaron Bertrand talks about how he's used it, and he does some comparisons on how it functions and performs as compared to other more verbose ways of doing pagination within SQL Server. So if you have an application where you need to show maybe there's 10,000 records that could get pulled. And obviously you can't show 10,000 records to customers on a screen. So maybe you show in the first 50. And then maybe they have the option of seeing the next 50, or they can skip ahead to, I want to skip the first 50 records and I need to look at the next 50 after that. So you can use offset fetch for pagination to do those sorts of things. There's a new syntax for raising errors. It's called throw. You can, for the most part, replace the older raise error. There's nothing wrong with raise error. Throw just lets you do it with less typing. And so throw is definitely an option in newer SQL servers to let you do the same thing with less typing. There are a bunch of date and time components where you can pass variables into these particular functions and build dates and times, or even date time values. The one that I found the most interesting and valuable is that EO month. That particular function will prevent you or your colleagues from having to write their own user-defined function that gets called every time you need to know what the last day of the month is, for example. So that's a useful feature that I was actually telling a colleague about just a few weeks ago, because I came across some code where he was calculating end of month in order to do some work, and he was not aware of the EO month T-SQL feature that came out in SQL Server 2012. There also is the inline specification for clustered and non-clustered indexes. So, and we'll see some examples of this in just a few minutes. There's drop if exists in SQL Server 2016 Service Pack 1. So what this does is it shortens the syntax needed to check if a table exists before you're going to make it. I've seen all sorts of code designed to help you check if an object is there before you do something with it. Drop if exists is just a much shorter way of doing the same thing. Create or alter can be important for query store. So create or alter works on a number of objects, but most importantly in relation to query store for stored procedures. So again, instead of checking if something exists and then making it, you can do create or alter. Create or alter stored, my great stored proc. What that does is it will create the procedure if it doesn't exist. It will alter the stored procedure definition if that procedure exists already. The reason this is important for query store is that when queries run inside query store and they're captured, they're given a query ID. And so if you run a stored procedure and you get a query ID of 1 for that stored procedure, if you drop the procedure and then recreate it with a new definition, the query ID now changes. It's not 1 anymore. So you lose the tracking of performance for that stored procedure inside of query store. If you use create or alter instead, every time you need to change that stored procedure, the query ID of 1 stays the same. And so in the query store reports that will track and trend performance of a particular query ID over time, you can see how your changes might be impacting or affecting performance for that particular stored procedure. There are a number of things in terms of JSON format. I actually, when I went to the St. Louis DevOps conference, there was a person there named Hassan Savran who did probably 30, 40 minutes of his presentation on JSON in SQL Server. And I learned that there have been new and improved ways of dealing with JSON even as recently as this year in Azure. So if that's something you're interested in doing or checking out, you can. I'm not saying, I'm setting aside the question of whether you should do JSON in SQL Server. I'm letting you know that you could experiment with that if you wanted to. So let's look at inline index creation. So how did this work? You can create the table and then in line right there in the table create statement, make a filtered index in this case. You can do the same thing with a multi-column non-clustered index. So you just put in your columns and then index name, non-clustered, and the columns that you want. And I think this is great because it prevents from having to do a whole create non-clustered index, blah, 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 kind of syntax on after you've done your create table. And a lot of times you kind of know as you're developing a table for a particular feature or product, what columns might be used most frequently. And you can start with a set of indexes that make sense right in your create table statement. You can also do this with unique multi-column, and you can do unique clustered as well using this inline index syntax. So this is kind of a side-by-side of different concatenation methods. So the top line uses the plus and single quotes to create spaces. Then you have the newer concat option, and then you have concat with separator. And I'm just putting them side by side so you can see the amount of typing involved in these things. Certainly, I think there's a lot of different movements with your hands on the keyboard, you know, trying to do shift to hit a plus and for that top line. And I think the amount of typing and what you're having to do with your hands to get the same query results is better with concat or even concat with separator. And this is just a screenshot to show you get the same results. So you might want to check out concat and concat with separator in order to help you do less typing and get the same query results. There are some enhancements for T-SQL in SQL Server 2022. Greatest least, generate series. There's some string split with enable ordinal enhancement has been put into the product. I know that was one thing that had been asked for quite a lot with string split, was having some kind of ability for that enable ordinal. Let's take a look at greatest least or talk about that. Let's say you have a platform that allows customers to manage email subscriptions. You have a newsletter and you need to know how many people are opening up that newsletter. So I took a look at Aaron Bertrand's article about this, where he talks about greatest and least and how he would use that sort of thing. And you can check out that article at the bit.ly link there. And he went through a couple of different methods of showing how to get that information. So he created a table that has year and a number, and then year in, and then an integer value for each month. So what this is this would be the number of opens that happened for your newsletter in that particular month. So then he wrote some code. How would I get the summarized email opens? How would I get the information about greatest and or the month with the greatest number of newsletters that were opened and the month with the smallest number of newsletter opens? Here's some sample values that he put into the table. So this is a case statement. This only gets the first 3 months. Notice in the case, it just has January, February, and March. So this is just 3 months worth of data. That's a lot of typing just to get 3 months of information. It gets better a little bit. You can use cross apply to do this. So in the inner query, he's getting the year, and then he's getting the monthly total for each month. And then at the top, he's using max and min to find the best month and the worst month. So still kind of a lot of typing. So before I show you the next screen, remember we went from this to this to this. I don't know about you, but that looks like a lot less typing. to get the same information with greatest and least. So I would encourage you to check out greatest least if you have to do something similar in your particular application. Okay, I'm going to have to move a little quicker through high availability and disaster recovery. Do we have any questions before I dive in?
Yes, Lee, a quick one from Srinivas again. When searching history table, it is better to create index on history table to speed up the query. It's probably a question. So is it better? And then appears only clustered index is created in history table from original table and not non-clustered index are replicated.
So I need to do some testing of my own there to see. I don't know if you have to keep the indexes the same or not between the temporal table and the history table. That's an excellent question. I haven't done that particular test with that. My guess is that you're able to have different indexes on the temporal table versus the history table in order to suit your queries. The only requirement I know about is that you have to have the primary clustered key.
And the second question from Srinivas also, how do you know which month has greatest or least? Only greatest hyphen least values are returned.
So if you go back to here are the values that were inserted, and let me see if I can. So what this is going to do is for the year 2021, January starts at the left and you have December at the far right. Greatest is going to find the greatest value for a particular month. Least is going to find the smallest value for a particular month. So just like you have here where he's doing best month equals max of the monthly total, min monthly total is worst or the least. Greatest will get you the months from January, February, and March. Which of those 3 months had the most opened emails or opened newsletters? Worst month equals least would be which of those 3 months up there had the least number of opened newsletters. Hopefully that answers your question. If it doesn't, let me know and I'll try again to re-explain. So high availability and disaster recovery. So you're probably looking at that and saying, Lee, I thought we were talking about modern features. Yes, we are. Sometimes to understand what you get in a modern feature, you have to remember what you had before the feature came along. So log shipping, you have log shipping, database mirroring, you have failover cluster instances. These all give you various ways of achieving high availability or disaster recovery. They also have restrictions to them. So log shipping, if you're using a readable secondary, for example, in standby, then your data is often, as soon as you go to standby mode, your data is not up to date anymore. In log shipping, you don't have a single built-in connection name. So if you failed over to a secondary, now your application, you have to change where your connection happens. Log shipping is designed for single databases. Database mirroring has its own problems or its own limitations, not really problems, but there are restrictions. Secondaries aren't readable. You can do database snapshots, but database snapshots come with their own complications. And again, database mirroring really is a single database configuration. You have replication, lots of moving parts. You gotta love agent jobs for this, right? You have to have a primary key on every replicated table. Lots of systems, databases that I've come across don't meet that requirement. So replication is out because I've tried to go back to teams to get them to add primary keys, and that's a battle that I really never won. So there's no single built-in connection name. They're just restrictions for these different options. Failover clustering. You have to have shared storage or some kind of shared storage trickery required by, SAN replication or a piece of software that makes it look like their shared storage. And clustering only provides high availability in and of itself. So what new feature tries to address these things? It's going to be something that we all know about, which is availability groups. It came around or came into existence in 2012. Lots of enhancements for availability groups all the way through SQL Server 2022. How availability groups try to address the limitations that we talked about. So in availability groups, you don't have shared storage or shared storage trickery via some kind of software. So that kind of solves the failover cluster instance obstacle. It does provide built-in disaster recovery using multi-subnet configuration. So that solves the issue of failover cluster instances only have local high availability. You don't have to have a primary key in order to use availability groups for a database. You can replicate the entire database and you don't have to worry about making sure there's a primary key everywhere. There is a built-in connection name for availability groups called the listener, and that solves the issue of log shipping and replication, not really having that built-in connection name that doesn't change regardless of failover. Data is within a few seconds of the primary, and that solves the issue of log shipping using log shipping standby, where you're out of date as soon as you go to standby mode. Readable secondaries. You have a couple of options for readable secondaries. You can direct connect to the secondary instance. You can also use read-only routing feature using the listener. And that solves issues that we saw with mirroring and log shipping. There is automatic failover for a group of databases. So that solves the issue with mirroring, log shipping, replication, where the setup is only for a single database. Availability groups are relatively easy to leverage for upgrades. I did one recently where we had SQL Server 2019. We had a 2-node AG. We built 2 additional nodes, put SQL Server 2022. We joined those nodes to the existing Windows failover cluster. And then we just failed over to the SQL Server 2022 instance once it was synchronized as a secondary. And then you remove the 2019 nodes from the availability group. You remove those 2019 nodes from the cluster, and you're left with 2 SQL Server 2022 nodes in an availability group. I know that distributed availability groups are also an option for doing this. We didn't go down that particular path. Availability. Other options or positives for availability groups are the automatic page repair. In SQL Server 2022, you do get contained availability groups, which helps you deal with managing objects outside of the database. One of the drawbacks potentially of availability groups is that you do have to manage you have to manage logins and agent jobs and a number of other things. And that was kind of a challenge before SQL Server 2022. I have not experimented with contained availability groups. That is something that's kind of on my to-do list. I'm going to move through that. Here is a multi-subnet setup where you have high availability on the left. You have disaster recovery via secondaries on the right-hand side. I will tell you a brief story. If you have to do this in AWS IaaS, you're using EC2 instances, for example, there are some gotchas here that if you don't follow, it's going to be very, very painful for you. Every one of these nodes has to be in its own subnet. And if you don't do that, then automatic failover doesn't work. If you discover that has not been done a few days beforehand, If you have a deadline that's coming up and you don't discover until a few days before the deadline that that rule was not followed, it's going to be very painful for you. Um, I've lived that experience. Once you get into that situation, especially like if you're using EBS volumes that you've already restored terabytes of data on, you don't have very many good options to how do I solve this and still meet my deadline. So you want to be sure that you understand how your cloud provider handles availability groups and infrastructure as a service. You also need to be sure you have proper team members. It does take a little bit more to support availability groups than, say, log shipping or replication or even database mirroring. I talked a little bit about requiring availability groups to be multi-subnet for AWS. Every instance has to be in its own subnet. There are a couple of different storage options, and I told you, briefly the little story about upgrading SQL Server availability groups in AWS. So, accelerated database recovery. This is a feature that essentially will let the system use what's called the persisted version storage. It's similar concept to what happens in recommitted snapshot isolation, where you have versions of rows that are stored in the system as changes happen. And accelerated database recovery uses those row versions to, in some cases, skip parts of recovery completely. You get a different recovery mechanism. You get a different crash recovery mechanism with accelerated database recovery. I would really encourage you to look at this. I have used this feature to resolve issues where systems that were patched would take, because of the activity that was happening in them when they were being patched, certain databases might take 15, 20, even in some cases, yes, 30 minutes before that database would run through the traditional crash recovery and come online. When I turn on accelerated database recovery for that database, the database basically is up almost instantaneously, just like I would expect and hope for in the first place. There are some settings for it that can help you help the system clean up versions and do the accelerated database recovery for more than one database at a time in SQL Server 2022.